Hello, students. We are into the homework from section 5.1. And 5.1, if we scroll down here, says 1 through 8, 11 through 17, 19, 20, and 22 to 26. Let's take a look at those problems. So find the additive inverse of each of the following. Again, that should be pretty quick. I hope so. For some of them, there's multiple ways to write them. So it does say write the answer in simplest form possible. When they say that, what they're saying is write it in the using the least symbols that you can. Let me give kind of a quick example there. So if I was looking at the integer -5 and someone said find the opposite or the additive inverse, I could write it as the opposite of -5, and that would be correct. That is the additive inverse. But when they say write it in the simplest form possible, remember the opposite of -5 would just be 5. So this would be the simplest. Even though the one above it is completely the same quantity, it just looks more complicated. That's what we're getting at there. Let's see here. What else do we have? Simplify each of the following expressions. Evaluate each of the following expressions. Use the following value definitions of addition to find the following sums. Again, I think the only issue, where would I flag people here? Opposite of an opposite? Probably not. Usually that works out pretty nice. Oh, here, absolute value. So the opposite of an absolute value. So if you had the opposite absolute value of -11, what I would ask you to do is just remind yourself, what would I do if it was just the absolute value of -11? Well, the absolute value of -11 would be 11. Then once you're done doing that portion, come back up and say, wait a minute, but this was the opposite of that. So put an opposite symbol in here and you'll be good to go. So that's kind of the way that I would do it. Let's see here, 7, 8. Let me clear all these. Demonstrate using a chip model. So when it says, kind of demonstrate using the absolute value definition, then this one you would kind of say, okay, I need to take the absolute value of each and find out which one has a larger absolute value. In this case, absolute value of 31 is larger. And then I would say, oh, but that means I would do subtraction between the numbers as if they were both positive numbers, and then I would use the sign from the larger. So I'd use the negative because this one over here is negative. The chip model, yeah, try using, you could use B and R, B for black, which is positive, R for red, which is negative. And you could also use the plus or minus if you prefer to use that. Both of those would be just fine. Demonstrate the additions in 5 using a number line model. Okay, so that's just very similar, just kind of going one direction or another. And then you have to use a number line to find subtractions. And then you have to do the subtractions using the chip model. Okay, so again, basically a chip model for addition and subtraction, number line for addition and subtraction. They might as well just have said that. All right, let's take a look. What else? 1 through 8, 11 through 17. So let's see your question wise. Write an addition or subtraction problem and then solve the problem. So hopefully this isn't you, but it does happen to many people from time to time. You end up with a negative balance in your account, so you got to go dump some money in. But again, sometimes the money you dump in doesn't cover it. Yeah, even though you deposit a check for $62, you do not have $62 in the bank because you were already in debt by $45. All right. 11 through 17. I think most of these are pretty self-explanatory as you read over them. When it says compute the following, this would be order of operations style. Let's move on. 1670. Prove that for all integers x and y. Okay, so there's a little proof. And simplify. That's 11 through 17. I did not give a magic square. I think I only did one of those back when we were doing it. So let's see here. 18 is out. Then 19 and 20. Let y equal -3x minus 2. Find the value of y for each of the following. So you're going to plug that in for x and see if you can find the value of y. That's 19, 20. Determine the number of terms in the arithmetic sequence. This is exactly what we did back in chapter 1. And so it shouldn't be an issue. You can use the algebraic approach, or you could use what I've done before in class where I kind of showed you would add or subtract something to make a sequence that's easier to work with. So that's 19 and 20. And then 22 to 26 right over here. Find all integers that make this true. So what number can I put in for x to make this quantity true? Yeah. Arithmetic sequence may have positive or negative difference. So, okay, that's fine. We saw that back in chapter 1. Classify the following as true or false for all values of x and y. This is probably a good one for you to do kind of plugging numbers in as you do go forward. So for part A, I'd be plugging in values for x. Plug in x equals 1, plug in x equals 5, plug in x equals -5, and kind of see if it does work out. Okay, and then a little bit of solving equations that links back to the algebra that you have had in a prior class. That's it. I showed a few examples. I kind of talked through the big picture on the others, and hopefully that's helpful. If not, just kind of let me know which questions you're struggling with, and we'll make it a separate video about those specifically. All right, off you go.